28 bits. So you do not know your IPv6. You cannot say your IPv6 address to a fun one, or to ::1, or ::53, or whatever. Right? It derives from your public key. And then, of course, it's not enough. You need to do send. This is what send is doing. It's basically using then your private key to sign each and every neighbor discovery message. Okay? So now, the recipient, when you claim to get an IPv6 address, to claim to have this CGA, okay, you receive the packets coming from this address with the public key, so I can redo quickly as the recipient the same map, and I can check, yes, this IPv6 address has been computed based on this public key, and then I use the public key to verify the signature of the mapping between the internet address and the IPv6 address. Done. No need for certificates there, right? It's just a proof of possession, of ownership of a v6 address. It does not prove you that you have the right to use this v6 address. It just proves you that the mapping between the internet address and the v6 address is this, right? No certificate means there is no CA, we have no authorization there, right? It's just a secure mapping, that's all. Which is already pretty useful, right? With this, ARP spoofing, I mean for v6, does not work anymore. So seeing the share between v4 and v6, a lot of things is identical. Sniffing is the same. When Justin was talking about SQL injection, of course SQL injection over HTTP over IPv4 or over IPv6 is exactly the same. Okay. The only attacks I have personally seen on my servers were brute force attack against SSH over v6. I'm pretty sure that the attacker has no clue that he wanted to go over v6 to my PC or to my server. Right? He was wanted to attack Vyncke.org, and he was bombarding me with a brute force attack over v6, but he doesn't care. Flooding, this is of course all the denial of services you can do as well over v6. One issue which is also shared are bugs. Okay, there are bugs in v4, there are bugs in v6 implementation. So I put there, we need to refresh, but basically each and every operating system, okay, whether it's a BSD derivative, Linux, Microsoft, Apple, everyone got bugs and still having bugs. I put Cisco there. iOS is basically the operating system of our routers, but be confident other vendors are doing the same problem here. Okay, so bugs. The good news, IPv6 is more and more deployed, so bugs are found and fixed. Okay. Not the bad news or good news, it depends on which side you are. There are multiple tools for it, and Scapy, which I use a lot to generate packets or attacks packets to see how things behave, is now working very well with IPv6. So it's even incorporated now. Okay, what's the first part? Basically, the good old tricks, ARP spoofing, reconnaissance, coming from v4, applicable to v6 as well. So now, let's move to the right part, maybe the more interesting one, specific IPv6 issue. And the first one is that a myth, I really consider it a myth. People say, because IPv6 and IPsec are tightly linked together. Okay? It's stated into the RFC, so a standard from the IETF, if you pretend to be an IPv6 node, you need to have IPsec. You need to have the implementation of IPsec. You do not have to implement it, to use it and to configure it. Okay. Vastly different. So you can perfectly be an IPv6 node with the IPsec code and not use it. So it's legitimate. Some people again says, hey, great, every node IPv6 is using IPsec, so first it's not true, okay, as we have seen. And if everyone is using IPsec, then we are safe. I mean, if you think twice, it's not the case, of course. If you want to use IPsec in a secure way, you need to get strong authentication. Can we scale any PKI to, remember the big numbers of nodes I've put with all the addresses? No way. Okay. And moreover, if you do this, it means if everything is encrypted, then everything which is in the middle, intrusion prevention system, firewall, sniffers, lawful intercept, or whatever tools that is a good guy you want to use to protect your network, are blinded, okay, because everything is encrypted. So I don't personally consider that using IPsec everywhere will solve all the problem. So of course, use IPsec when it's needed, right? Don't take me wrong, I love IPsec, but don't use it everywhere. Also, one of the biggest challenge, of course, is that IPv4 and IPv6 protocols are not, you cannot interpret easily between each other. Okay, you cannot send an IPv4 packet to an IPv6 without any magic inside, in the middle. This is all we call transition techniques. And it won't know one day, we won't say on the 1st of January 2011, hey, please, to say to my father, throw away your Windows 95 and replace it by Windows Vista that support, for instance, V6. There is no red flag day when you declare, yes, V6 is now. No. Okay? So you need to get a gradation, a coexistence. And there are multiple techniques. One, which is by the way my favorite one, is dual stack. Dual stack because you get a TCP IP stack for V4 and a TCP IP stack for V6. Dual stack is the name. So your PC runs two protocols. Okay? And I guess by looking at the PC here, each and every PC in this room is dual stack. Okay? So it means now, if you think about the OS security, you need to think twice indeed. Because you can be attacked not only about over IPv4, but also about IPv6. Meaning, for instance, if you are running any Linux, which is running V6 natively as well, so enabled by default, not only you need to configure IP tables, but also the V6 version of IP tables, which is IP6 tables. If you forget about it, you got a big issue. Okay? Still easy to understand for you. Now think about your little sister or your girlfriend or whatever, which is running a laptop with Vista on it. Right? It needs to be protected by both as well. And as soon as you don't apply the same security policy for packets coming over V4 or packets coming to V6, you are into trouble. Because the potential attacker will attack you on the weakest link, what we call fate sharing, right? You are as strong as the weakest TCP IP stack. And an example that I really love with a yellow smile here, this is basically what a product from Cisco, which is behaving badly, which is the IPsec client. Okay, this is used basically to connect a PC or a Mac from this place, for instance, safely to your corporate network. And it can work in what we call no split tunneling. The red stuff is the IPsec tunnel. When you apply no split tunneling, it means that all, when you read the paper, all IP packets needs to go from the PC into the tunnel to corporate, where basically you get firewall and IPS. The goal is that nobody can hack or control this PC by using any kind of botnet or command and control channel and jump over V4 and jump into the tunnel to attack your network. Okay? This is no split tunneling. Great. But they say IP packets, meaning that's IPv4 packets only. So now if an attacker sends you an attack over V6, this packet will be received by the PC, even if there is no split tunneling. Right? Any clear text IPv4 packets are dropped with this. Any IPv6 packets are accepted. Okay? So if the command and control channel of a botnet is over V6, and they are already, it goes through. Okay? Really, really bad. If you know about it, it's okay. Right? But a lot of people don't know. And for instance, my biggest problem with IPv6 and security is this one. You are running a host like Vista, okay, or Mac or Linux or anything, and you know that you need to use IP tables. You need to configure your IPv4 security, but you have no clue about V6, but it's enabled by default. But you say, hey, I don't care, right? My network at home, at the office, doesn't run V6, so I'm safe. What you say? You're safe. No way. Okay? If any of your PC is associated to serve host space IPv6, which is the IPv6 enabled wireless LAN, your PC, right, was sending for 1 year, 2 years router solicitation. Hey, is there any V6 router nearby? And he was trying every minute for a couple of years. This morning it started. Somebody replied to it. Okay? A router from Megacom basically replied, yes, there is a V6 router.